about the carbonyl compounds like aldehydes and ketones. In particular, the chemical properties of aldehydes and ketones. In the category of chemical property, the first and foremost thing, nucleophilic addition reactions. In the nucleophilic addition reaction, the reactivity can be compared among the aldehydes and ketones. And we know the carbonyl compounds are containing C double bond O in their functional group. The compound 1, here I am writing the formaldehyde, and other one acetaldehyde, CH3C double bond OH. And third would be the acetone, CH3C double bond O CH3. The compound which are written here are listed out. The number 1 is formaldehyde. Number 2, this is acetaldehyde. And the third one, it is acetone. So 3 compounds were written. If you take acetone, first of all, in which oxygen is electronegative, that carries minus, slightly minus, more electronegative. It attracts a sad pair of electron towards itself. Hence it is carrying slight minus. And carbon is carrying slight plus. So this makes the polarity between the carbon and oxygen. In this condition, if you supply the nucleophile, we know what are called nucleophile. The group of atoms which are carrying negative sign, the electron rich species is said to be the nucleophile. So the nucleophile can attack this carbon. While attacking, what is happening? The pi bond in between the carbon and oxygen breaks up and electrons will be carried by the oxygen. See, in the case of acetone, there are 2 electron releasing groups present. These 2 groups are called electron releasing groups. Actually, due to the presence of this electron releasing group, plus I effect inductive effect, plus the inductive effect increases. It is releasing electron towards the carbon. And this is also releasing electron towards the carbon. And this makes the electron density on the carbon atom would be greater because these 2 groups are releasing electron towards the carbon atom. So when the nucleophile is attacking this carbon, nucleophile is carrying minus. This carbon is also electron rich. So what may happen there? There will be chance of electron repulsion. Negative sign repulsion. So that's the reason why this acetone may have lesser reactivity with the nucleophile. But see, the formaldehyde, in which there is no such kind of electron releasing group. So no inductive effect is operating here. So that the nucleophile can readily attack this carbon, the nearby bond can be broken down. But if you take the acetaldehyde, it contains only 1 electron releasing group. So slight increase in the electron density, the attack of nucleophile is less favored. It clearly shows that among the formaldehyde, acetaldehyde and acetone, formaldehyde is more reactive with the nucleophile and acetaldehyde is lesser reactive, acetone is least reactive. This reactivity is based on the plus inductive effect. plus inductive effect increases means the reactivity decreases. Otherwise, we can say the reactivity with the nucleophile is inversely proportional to plus I effect. In the case of acetone, the plus I effect would be greater. So the reactivity is falling down. Based on this, certain properties can be discussed for the aldehydes and ketones, in particular the nucleophilic addition reactions. Okay. Nucleophilic addition reaction of acetaldehyde. The very best example for this category is action with HCN, hydrogen cyanide. How acetaldehyde is reacting with the hydrogen cyanide? Acetaldehyde is having this formula. The compound is called acetaldehyde. It is to be treated with hydrogen cyanide, HCN. Now, this can be dissociated to form H plus and Cn minus. Among these two, the Cn minus is called as nucleophile. There are two steps in this particular reaction. The step number 1 is attack of nucleophile. On carbon plus. Step 2, protonation of oxygen atom present in the carbonyl group. What is called protonation? It is nothing but the addition of H plus. Just see the arrow marking, the Cn minus, it provides the electron for the carbon. The arrow indicates that Cn minus is attacking the carbon. The nearby bond breaks up and oxygen can carry minus. So this oxygen is supplying electron to this hydrogen. The hydrogen plus is added with this oxygen. That particular stage is called as protonation. Just execute both the steps and you can have an addition compound, CH3, CH, here it becomes OH. After the substitution it becomes Cn. The compound's name, what is it? It is to be called acetaldehyde cyanohydrin. Now this acetaldehyde cyanohydrin, on hydrolysis, what happens? The cyano group can be converted into carboxyl group as follows. You see, this is a cyano group, C triple bond N. During the hydrolysis, for your easy understanding purpose, I can write the H2O. Just we are adding oxygen and hydrogen so that it becomes amide, C double bond O NH2. On subsequent hydrolysis, you just add HOH so that it can be transferred into carboxyl group like this, plus NH3. The conversion shows that the Cn after hydrolysis, it becomes COOH. So the C triple bond N, on hydrolysis it becomes amide. Amide on further hydrolysis it becomes carboxylic acid. So whenever if you want to transfer the cyano group into carboxyl group, the cyano is to be hydrolyzed so that we can have a carboxyl group. So with the help of the same, the CH3 CHOH, the Cn is becoming COOH. So it becomes an acid. This acid is nothing but lactic acid, an optically active acid. It's another name. There are 3 carbons in a row, so that we can call this as propionic acid, in which the alpha carbon, carbon next to the functional group, alpha carbon is contained in the hydroxy group, so that we can call this as alpha hydroxypropionic acid. Otherwise, second carbon is having the OH. You can call this as 2-hydroxy, IUPAC name, propanoic acid. This is the IUPAC name of the compound, propanoic acid. Common name alpha hydroxypropionic acid, and it is also called as lactic acid. It's an optically active compound. Why this is called so optically active? The carbon, which is bonded with 4 different groups, so that we can call this as asymmetric carbon. What are all the compounds containing asymmetric carbon? And a compound and its image are not superimposable, means they are all optically active. And thus this compound is optically active as it is containing a symmetric carbon. So in this way, the nucleophilic addition of acetaldehyde is explained, and it's going to be an important conversion, how to convert acetaldehyde into lactic acid. Treat that with HCl followed by hydrolysis. 2 steps are there. In the addition of HCl, there are 2 steps, attack of nucleophile and protonation. Okay.